Hello everyone, and welcome back to the Fluctus Channel. Divers have played an important role in the U.S. military since the beginning of the 20th century. Many units and teams focused on underwater activities have been created in the military forces to increase their capabilities for action in any environment. This includes the specialized units from the U.S. Navy Seabees, called the Underwater Construction Teams. Such groups are composed of divers qualified in both underwater construction and underwater demolition. Those teams were created in the 70s to formalize the construction activities under which the Seabees carried out sporadically. Initially, each team was modest in size, consisting of 1 officer, 1 chief petty officer, and 12 to 15 Seabee divers. However, over the years, they further expanded their manpower and training capacities, ready to play an essential role in supporting the U.S. Navy's global operations, providing specialized underwater construction and repair services. The complexity of the tasks carried out by UCT members implies high levels of preparation to ensure that objectives are met safely and quickly. This is why training exercises are constantly carried out in different conditions and equip the divers with the necessary skills to perform underwater tasks. The training program has evolved since its inception, reflecting the increasing complexity of underwater construction missions and the need for highly trained and specialized personnel. Nowadays, training is divided into different stages, designed to build on the previous one and ensure that the diver captures all the necessary knowledge. During approximately 23 weeks, the divers will get the basic engineer diver course comprising topics like dive physics, surface-supplied air diving, and underwater construction techniques. With this training, the students gain proficiency in construction tasks like underwater welding, cutting, and surveying maritime environments. When completing the course and getting a couple of years of experience, divers can explore the advanced course focused on diving supervisor training and demolition operations supervision. By doing this training, divers have the skills to carry out a large number of activities, including maritime infrastructure evaluations. These assessments involve studying in detail the physical condition and capacity of marine facilities. With their training, UCT divers can use a wide variety of tools and techniques to collect data on the condition of structures, such as docks and mooring systems. The latter is essential to secure vessels in port, so their integrity is necessary for the safety of ships and the dock. When inspecting such systems, the divers use several methods. The simplest of those involves just visual inspections done by the team, looking for any signs of wear or corrosion in the structure. However, this type of review is not enough, so more advanced devices, such as ultrasonic sensors, are used to measure thickness, or bathymetric instruments to map the floor around the mooring system. Similar, or even greater complexity occurs during underwater drilling and welding operations. In this case, the tools used have a greater risk for the diver and can cause a drastic effect on the surrounding environment. Therefore, to carry out these operations, the team must create a planning schedule, so the work will generate the smallest effect on the marine environment. When using tools that generate high vibrations, such as pneumatic or hydraulic drills, the attachment points must be managed so that the diver can ensure the position of the tool. In the case of welding, the process used by divers is hyperbaric welding, which can either be wet in the water itself or dry inside a specialized enclosure. All this knowledge is necessary to carry out not only construction work, but also underwater demolition. Such operations occur when it is necessary to remove obsolete structures or clear hazards when preparing a new construction. These procedures generally begin with evaluating the structures to be removed, as well as the surrounding conditions and their vulnerability. This study allows the team to create the demolition plan and determine what methods they should follow to achieve the best result. Before placing explosives, divers typically clear the area around debris or other obstructions using hydraulic tools or other equipment. Divers wrap explosive cutting tape around the structures, like piles or beams, to cut through the material efficiently and allow the team to remove the parts easily. Being prepared for a wide range of conditions, UCTs can also serve as support in emergency cases, such as a plane crash on water. Their experience in aquatic operations allow them to assess the situation and begin planning recovery procedures quickly. They usually carry out those processes alongside other agencies, such as the National Transportation Safety Board or the Federal Aviation Administration. These specialized teams must be completely familiar with the equipment during these exercises and actual rescue operations. This equipment is crucial for rescue missions to be successful and efficient, and involves advanced technology to support the complexity of the procedures. The most important elements are the equipment for divers that involve oxygen supplement systems, like surface supply equipment, and equipment for deep dives, such as full face masks equipped with communication systems, as well as the rebreathers that can recycle exhaled gases. This all goes with dry suits that keep divers dry and insulated from the cold and maintain body temperature during prolonged operations. In case the environment is in warmer waters, the diver can use a more common neoprene wetsuit that still provides enough thermal insulation for those conditions. However, in difficult conditions, divers require more tools in addition to their basic equipment. When in murky waters, such as rivers or lakes, divers have low visibility, making it difficult for them to do their jobs efficiently. This has encouraged the development of new technology that solves this problem, such as the Diver's Augmented Visual Display. Such a device uses a virtual image projection system that translates the signals of a waveguide optical tool and a sonar into a visual display. By using such technology, the divers can overcome the limitation of zero visibility by receiving real-time augmented reality displays. Some of the instruments used in underwater operations focus on ensuring divers' health, considering the high-risk conditions in which they find themselves. One of these risks is decompression sickness, which can lead to joint pain, headaches, and, in worst cases, pulmonary and neurological damage. It can be solved by doing decompression stops, where the divers ascend slowly. However, during emergencies or in conditions where rapid ascent is necessary, a recompression chamber is used to allow divers to complete their decompression stops. To use the chamber, divers must prepare before any activities underwater to have the best physical condition to endure those hard conditions. Medical checkups are done to inspect nitrogen saturation and cardiovascular health. When underwater, that saturation can lead to decompression sickness, which is why the surface team prepares the recompression chamber. This pressurized tank is generally configured with pressures between 300 and 450 psi. In addition, the temperature, humidity, CO2 levels, and oxygen levels are controlled through a system of valves and electronic controllers. During treatment, the divers use breathing masks inside the chamber to breathe 100% oxygen, which helps dissolve the nitrogen bubbles inside the body. Another high-risk condition for divers is low temperatures on missions in the polar regions. For example, when they must conduct inspections and maintenance operations on the hull and propellers of ships. Dry suits, umbilical cables, heated gloves, and boots are just some of the gear those divers need to handle extremely low temperatures. Once in the water, they look for any damage caused by the ice and corrosion due to the long exposure to the ocean water. The number of hours and dedication put into training excellent divers demonstrates the importance they have when carrying out operations effectively. The high risk to which they are exposed has also driven the development of new technologies and devices that speed up work and provide greater safety for the diver. This gives rise to the emergence of new methodologies and new systems in the future. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.